Hello, this is Mr. Jackson, and today I want to talk about forces. A force is basically defined as a push or a pull on an object, okay? And when you push or pull on an object, you apply a force. And a force, it can be defined as this, but also it has units. And the units for a force is called a Newton. And a Newton has the symbol N. And that way you would put after numbers. So like 10N would be 10 newtons. It means it's a force that is acting on an object. And as we go forward in the units to come, we're going to need to be able to identify forces acting on objects. And so today I just want to do a basic idea of what kind of forces are out there, the most common ones, and how they're going to look in our applied physics program as well as in our books. Okay? So the first force we're going to run across quite a bit is weight. And weight you can define as a W or a FW. I use a lot of FWs, meaning it's a force, but it's the weight portion of force. Okay, and the weight is a force that acts downward due to gravity. Okay, and you want to remember that we can identify it by an arrow. We're going to be using arrows. So if I have a box sitting on a surface, the force of weight would basically just act downward, FW. Okay, but remember, even if a box is sitting on an incline, if this is the Earth's surface, the force of weight still acts downward. So I want you to understand that. Let's say we have a rocket flying through the air. Okay, so this rocket, it may be trying to travel upward because the rockets are firing. There is a force upward, but we're just identifying the weight. We know there is weight because there's gravity, and so as long as this rocket is near a planet, there will be a force of weight downward. Okay? Let's say that instead of that we have attached to our ceiling a plant. So you have this plant hanging from the ceiling, and this plant is being acted upon by gravity. Even though the Earth is down here and it's not touching it, there is force of weight. So anything that has a mass to it will have a force of weight pulling down on it. Okay? So anything that has mass does have weight. The next force I want to define is called a normal force. A normal force is a support force that occurs when two surfaces touch. So a support force between two surfaces. Okay? So here I have a box sitting on a floor. It could be sitting on a table. It doesn't matter what it's sitting on. But since two surfaces are touching, okay, right here, then we know that there is going to be a support force. The table is pushing up. So we're going to go Fn. Okay, and the reason why I don't like to make it an N, because also newtons is a symbol for the actual force itself. So this table, if this table did not support it, and then it would fall through and break the table. So this table is pushing back on the weight, which is acting down, and so it's canceling it out. So there is a support force. If I do this, and let's say we talked about this earlier, we have a force of weight acting down. Well, but there is a support force, but remember that you need to know this support force must be perpendicular to the two surfaces. So it must be perpendicular. So I'm going to put the word perpendicular here. And so this force would be in this direction. Force normal. Okay? So it must be at 90 degrees to the two surfaces where they touch. So it must be at 90 degrees. That will be more important later on. Here I have a rocket taking off. It has a force of weight, but since there is no two surfaces, hard surfaces touching, there is no Fn. Okay? And so then we have a person in a circus thing driving their motorcycle upside down through a loop-de-loop. And we want to look at it. Do we have some forces on here? Yes, we have force of weight acting down, but we also have a surface right here. We have these wheels touching this road or track, and so there is two surfaces touching. So this surface right here is pushing on it. This bike would then otherwise would go up in this direction, so the force is pushing down. So we know that there is a force normal, but this one is acting down because it's trying to overcome the surface that is touching in this direction to keep the bike from flying off. So force normal acts between the two surfaces at 90 degrees perpendicular, but to stop the weight, here the weight is acting, or to stop some kind of motion going in the other direction. So there is some normal force in this idea. Okay. The next force I want to mention is called a tension. We're going to call it as a T or an FT, force of tension. Tension is created when a push or pull is acting through a wire or a rope. So it's a force through a wire, a string, or a rope of some type. Okay, we call that tension. Okay, and so there's a tightness in that piece of string or rope. Okay, so here look at these situations. Here we have a person that is pulling on a box that is sitting on a floor, and to pull it, they create a force of tension. Okay, if we have this plant we had earlier hanging in our kitchen or in our dining room, we have the plant hanging down. Okay, as the force of weight acts downward, there must be a tension through these strings, so I'm just going to draw it straight up. There is a force of tension upward. Okay? Well, here we have a person pushing a box. Is there tension? No. If there is no wire, no string, or rope of any type, there is no tension. Okay? So remember, these are the key ideas: a rope, a string, and a wire. If there is nothing like that in the picture, then there's going to be no tension. So I want you to understand that. Next force we need to talk about is called an applied force or a thrust. These are pretty simple. These are forces caused by a human or a machine. And that's pretty simple. That means something is acting on an object. So here are four pictures. Here we have a car sitting on top of a lift in a garage, and they push a button and this thing pushes up. Well, this machine here is touching these two objects and it is pushing upward, so there is a force applied, or if I want to call it a force of thrust, that is fine. Okay, so that means there is something, a machine is pushing on that object. That would be a thrust. Here I have a rocket, which we have a force of weight acting down, but we see its rockets are firing, so its gases are being expelled, so there is a force of thrust upward. Okay? Here we have a car and someone's pushing on the gas, so let's say that they are accelerating. Okay? Then that means that the engine is working, there's a machine going on, so there would be a force applied in this direction. Okay? Let's say we have a person sitting on a bike, and this bike is moving. Okay? And so this bike, but they're pedaling. And if they're pedaling, then this human, just like another right here, see this person is applying a force right here, up here, I'm sorry. They're pushing on the box here. Instead of using a rope, since they're pushing directly, that would be a human force. That would be an applied force. So this would be force applied. Okay? But here they're pedaling, and so they're pushing on it, and gears on a bike are considered a simple machine as well as a human, so both of these fit. So there would be a applied force. Okay? Let's say I have a marble or a bowling ball sitting on an incline that begins to roll down. Okay? But no machine or human is making it roll. It's gravity. Then there is no applied force. So there is none acting there. Okay? It's just going on its own because of the force of weight. But there's no human or machine causing that to occur. If that makes sense. So these are forces we're looking for inside of our diagrams, because we're going to analyze which ones work together and which ones oppose each other. So like right here, I can have a force of weight acting down and a force of thrust acting up, and so they're opposing each other. Okay, and so I could have a force in one direction and then a force in reverse direction, so or they can work in the same direction. So it all depends. So we're going to have to get good at drawing these arrows for our next step at applying these forces and what they actually create and do. So the next couple forces really quick. One is called a drag force. We're going to call it FD or D. And those force of drag forces, so some pictures, is caused by air resistance. And air resistance always opposes motion. So it opposes motion. So we have to remember that. So if I've got a car going down the road, I might have a force applied, but there is air hitting the molecules on the windshield and the front thing, and it's slowing the car down. So there would be a force of drag backwards. Okay? So there is drag. Here I have a person riding their bike really fast here, or a motorcycle, and you know that they are also they have an applied force here. But since there's air resistance, they're hitting air molecules, there would be a force of drag. Okay, D or FD. Okay, here we have a rocket again. We've been bringing in our pictures. It's got a thrust upward, so force of thrust. Okay, but since there's air molecules in the air and they're hitting against the side of the rocket, okay, there would be drag. If I said it was in space, force of drag, and so it's always in the opposite direction of the motion. So if I'm moving this way, then the drag is that way. If I'm moving up, then the drag is down. Okay? But let's say I have a marble rolling on a table. If I have a marble rolling on a table, is it going fast enough to consider drag? And the answer is probably not. So slow moving objects, like pulling a box across the floor, okay, we're not going to consider drag. So we're going to say in this kind of situation, none. Okay? That's important to understand. So we're not going to consider air resistance an issue for very, very slow moving objects. Okay? So that's very important to think about. Then the last force is called friction. Friction is an opposing force, but it is caused by two surfaces. Two surfaces touching. And it is also an opposing one. Or opposes. We'll put opposes. So let's talk about friction for a second. Force of friction, let's look at situations. Let's say that you're pulling a box across the floor and you're pulling in this direction. You have a force of tension, but since the two surfaces are touching here, there would be some friction, so we would have force of friction. Okay, so there would be friction there. So I want you to point that out. Let's say we have a car driving along. I know we have force of drag. So here's an example. We have an applied force. Your engine, you're pushing your gas pedal. We have cars, and they're made aerodynamic because we don't want so much air drag. But there is a force of drag of air, but it's also touching the road. And we know that there is a force of friction because otherwise you wouldn't be able to turn your car around the corner. It would just slide forward. So there actually is a force of friction between tires of a car and a road. And there's quite a bit because those cars' weight pushes the tires hard into the road, and there's a force of friction. So here's an example, like I was talking about earlier, where there is more than one force acting in the same direction. And we'll talk about what happens when they do that. Here we have a rocket that is applying a thrust upward, okay, force of thrust, and then we're going, it might experiencing drag, but since there is no two surfaces touching, it's not touching another hard surface, there is no friction. Okay? So be careful. There may be drag, but there is no friction. That's important. Let's look at this person walking on ice. So what they're doing is they're applying a force. It's a human force, and they're applying a force through their foot, and they're pushing downward and backwards as their foot bends in this direction, force applied. But what happens is they can't get any grip, so their surfaces are touching, okay? But if they can't get any grip, they'll slip and their foot will remain, or their body will still remain in the same position. So this may have no movement, no motion, then there is no friction. Okay? Friction occurs when it opposes something moving. Okay? So there's going to be friction. So there has to be motion, and there has to be two surfaces touching. This has motion, but there's not two surfaces touching. So that would be no friction. But if they could move very slightly, then there would be a small amount of friction to help them move forward. Okay? The last thing I need to mention is the term neglect. Neglect, if he says neglect friction or neglect air drag, that means in the situation we don't need to add its arrow. So if I have a marble rolling down, he said neglecting friction, it means it's not big enough to worry to change the problem. So neglect means do not draw the arrow for that force. So if it says neglect friction, it means it's not an important factor in that problem. If it says neglect drag, it means it's not important. So you would not draw that arrow. If they do not mention neglect and you have a car moving, we're assuming that you would understand that it is time to put that arrow in your diagram. So I need you to understand these kind of names and to use them properly in the right direction and understand when they do occur. You are responsible for identifying them, even though they are maybe not mentioned directly in a problem. Okay? And that's our basics on forces.